Hello, and welcome back to Conquering the JavaScript Interview. Today we're going to be exploring the remarkable versatility of two essential array methods, reduce and reduceRight. They're often reserved for more complex operations, but these methods unfold the potential for a ton of different transmutations and computations. Like, did you know that you can implement other array methods as the reduce and reduceRight methods? That's pretty cool. So we're going to reduce our way to some more streamlined code by diving on in. But first, make sure you check out the description down below this video for a link to our community membership. For $25 a month, you get access to our front end and back end courses. Combine those two, and that is our full stack program. I also have made a standalone advanced React course that is also available, and I'm in the works of making a couple different courses that you'll get access to with that community membership. You'll also get access to our community in Discord, where you can get real-time help on your journey to becoming a better developer. So if you have interest in that, check the description down below. Otherwise, like I'd said, let's dive on in. So reduce and reduceRight. I was actually surprised to learn this were introduced in JavaScript's ECMAScript 5th edition ES5 back in 2009. Some of the previous ones I covered, such as filter and our friend find and findIndex in the previous video in this little mini array architect series, they were introduced at a later time, and I figured that something more complex like this might be introduced later, but in actuality it was reduced early on because it was meant to be versatile. It was meant to implement those other array methods until eventually, I guess, people wanted to have them just as native methods instead of having to implement them themselves over and over again using reduce. I thought it was fairly fascinating, right? Their roots are like traced back to functional programming paradigm, which emphasizes immutability, first-class functions, higher order functions, all those fun terms, HOCs and HOS. Those are a lot of fun to talk about. But yeah, they provide developers with a versatile tool. That's the whole purpose behind them, that abstracts the process of data transformation and accumulation. So, JavaScript incorporated these methods. It bridged that gap between, back in 2009 especially, between like traditional other programming languages versus JavaScript, which is newer on the scene. And, it made it feel more streamlined and gave us a functional approach to array transformations and computations, right? So yeah, it's pretty interesting to see how JavaScript, especially now I'm doing like this video series where I have to do like a little bit of background investigating and history checking on what I'm talking about in JavaScript. I thought it was fairly fascinating to watch how JavaScript evolved over time with these kind of methods here. So yeah, I think it's pretty obvious by their name what their difference might be and why I paired them for this video. We have reduce and reduceRight. Reduce is left to right, and reduceRight is surprise, starting from right and going to left. So that's the only difference between them. The basic idea for these algorithms are going to be begin iterating over items in the original array. For each item, you're going to apply an accumulator function to the current value and the accumulated value. Once all the items have been processed, we return that accumulated value. And it really is that simple to implement our own version of reduce and reduceRight. So, before I dive into that, let's go ahead and read the prompt and talk about some interesting code bits we're going to show off here. So, like everything else, it just says implement your own versions of these if you want to follow along, or just grab the CODEPEN from the description down below, and some basic intros here. But let's go ahead and grab one of these intros and work our way through something interesting here. I don't know how I managed to do that. We're going to do const nested array, and what I'm going to do is split this one apart into 3, 6, 7. Wait, how did I get 3, 6, 7, Luke? 4, 5, 6. I don't know what my brain just did there, but for some reason it just had a short circuit, y'all. Anyway, I want this little structure right here instead of what we were just working with, which is this little nested array structure. Yeah, the zoom level looks pretty good. This nested array structure to show you one of the cool use cases of reduce that you may not have considered before. Or again, if you're new here, not considered before, but if you've used it a lot, I use it a lot, then you already know all the things they can do. But for the newbies out there, let's show them what they can do. Or for if you've been coding like an intermediate level and you don't use reduce that much, try learning from these little examples and using it in some of your code bases. So like I said, it returns a new accumulated value to us, whatever that accumulated value happens to be. We can grab our nested array and reduce through it using the following function. We can grab that's our accumulating function, which we're going to use some shorthand here in just a minute. I want it to flatten an array, so I need it to return a new array, so my initialized value will actually be an array. So this is my initial value for my accumulator in this particular value. Every single iteration of this loop will give us access to the accumulator, which we're going to shorthand to ACK for accumulator. And then our current value is going to be represented by cur or element or whatever you want to call it. Really, it doesn't matter at the end of the day, right? So what we're going to say here is we need to return something. That's how we spit it back out to the accumulator each time. Let's call on the accumulator, which we know is an array, we can call concat and pass it the current value. So what this will end up doing for us here is, let's see if it worked, is it took each sub-array and concatenated it and basically flattened it into a singular array of accumulated numbers. A great example of how you can use the reduce method to basically do what an array map kind of does already, which we're going to show here in just a second. But it's a great way to flatten array values. Another thing we could do, for example, here is if we had like a list of users, just kidding, an array of users, and each user had like an ID and a name. We'll just do my cats. Well, technically, yeah, well, I'm not going to get into technicals here. We'll go name, Apollo, and Iserman. Okay, so there's some cat names, and this little, much better. There we go. We have an array of objects. So I talked about how data transformation is another great use case of our good friend, the reduce. So you can say cats object. So as you can see by the name of this little variable here, that we are going to change up how we are doing our reduce. So instead of an array, let's return an object. And the parameters of the accumulator, which will now be an object, and the current value, each cat object, I want to take the ID value of each object in this array and assign it as the new key of this object. So here's what I mean. We're going to take the accumulator, which is the object. We're going to give it a new property, which will be each cats.id, like that. Or rather, current.id, my bad. So it'll be cur.id. And it makes more sense now to call this cat because that's what each one of these represents. So let's call that cat instead of current. For each cat ID, assign it the cat, my goodness, I'm all over the place today, cat.name. And that will take the cat's name as the value, and it will make a new property that is the ID of that cat. And there we go. So we're going to basically transform this data structure from an array of objects to an object instead. And I have a huge error. What am I? Oh, I forgot to return. That's right. So classic blunder. I'm going to leave this in. I don't like editing out my errors because I'm human. I make them too. So basically what this is telling me here is that I did messed up by not returning my accumulator. So of course it can't take a non-accumulated object, assign a property to it and a value and things like that. There we go. Why is that error on the screen there? Oh, there it goes. Let's try running that again. Clear that out. There we go. But there you go. There is my new structure, which is what I was trying to talk about this entire time before I made that error. I forgot to return my accumulator between each iteration, so it had an error trying to make a property on something that wasn't an object. It would just crash, which is what happened. But this is what the data structure now looks like. Each ID is now the key of an object, and its value is the name or a sub-object or whatever I wanted to do. The point is, it's a great tool to transform data structures from one to another. And like I had mentioned and what you already saw, we can take, for an example, an array of numbers like that, and then we can do something cool like double numbers, numbers.reduce accumulator, comma, num. Makes sense for a variable name for me. I want it to transform, or we're going to implementing the array map method that takes an array of values, maps over them, and returns a new array based on some logic in there. So like last time, I can't forget to, right there, return the accumulator. And now we can say, hey, each accumulator, I wish to push in the current number multiplied by 2, as the name might imply, double numbers. And check it out. We have implemented the array map method using reduce. And that's all there is to it. For a video from earlier this week, we can even have if num is divisible by 2 evenly, then I want to push that into my array. So instead of double numbers, this can now be called even numbers filtered. So, oh, the name gave it away. Yeah, 1, 2, 3, 4, 5. I was like, for some reason, I thought I was looking for 6, 8, 10 still. And I was like, that's interesting. Yeah, so 2 and 4 are the only even numbers. And voila, we have taken reduce and now implemented a filter method, which is something we did earlier this week. And I thought it was worthwhile showing it in this video. Because, again, reduce is really powerful and very versatile if you understand how it can help you and what it does. So let's actually break this stuff down and try making our own version now that we've kind of messed around with what we do here. So as always, remember, modifying the prototype is something good to know how to do. It is great for interview-style questions and technical things, but it's something you should not consider doing on a large code base unless you are just really good at documenting and bringing people up to speed on the modifications you may make to native methods or new native methods you might be adding to an array object, for example. So yeah, keep that in mind. We're going to take that array object, we're going to add a new prototype called custom reduce. It'll be a function. And unlike our previous videos, this function will take 2 parameters. The callback function we're going to run, which will be the thing that gets the accumulator and the value and the accumulator and the current, for example. And we're also going to have our initial value, because you saw in most times, of course I deleted the code, but when I had like, you know, my reduce function like this, remember I had 2 parameters. I had my callback function and then some initial value. When I was implementing other array methods, it was typically another array. If I'm accumulating something like numbers, I might consider a 0. If I'm trying to concatenate strings together, I might start it as an initial value of a string. If you don't provide one, there are probably some fallbacks of what it's going to define to or stay undefined, for example. But nevertheless, that's that second argument, initial value after callback is what we're looking at here. So we're going to actually take this into account. Let's make our accumulator, and I'm actually going to write it out now rather than shorthand it. Let accumulator be whatever initial value we pass in. However, if we do not provide one, we should have a default. So we're going to say, hey, if that initial value is not provided, i.e. it is undefined, what we're going to do is say use the first value from the array. Remember that this context is the furthest thing to the left. If I'm adding custom reduce onto an array variable or an array object directly, then the context of this is the array. So this square bracket 0 will mean take the first element of the array because that is a good idea. If it's an array of numbers, it'll take the first number. An array of strings, it'll take the first string, etc. Just take on some kind of value rather than leaving it undefined because that could cause some errors. Otherwise, use the initial value if we don't provide one. So that right there is a really good way of writing some fallback code. Now, similarly, you will sometimes see this on Stack Overflow answers or Reddit threads or whatever. But, you know, from here, obviously, we need a for loop that generates and loops through this whole shenanigans here. But there's actually something interesting to think about as well for our initial loop. We can say let I equal, hey, if we have an initial value, or if we don't have an initial value, for example, we're going to start on element 1 rather than element 0. And there's actually a specific reason for this, and sometimes you'll see this written, and I want y'all to be aware of it, right? So we initialize the index. Remember, this is the index of our loop, I, our iterator. If initial value is provided, we start at the 0th index, okay? Otherwise, it starts from the first index because the 0th index is already taken as the accumulator's initial value. So this is some cool just fallback code to think about, saying if we already took if our initial value is already the 0th indexed value, so if it's like the array of 1, 2, 3, 4, 5, the accumulator is already 1, and we've already accumulated the first value of the array, aka the 0th index. So there's no point in reiterating over it. Therefore, we go to 1. So again, if an initial value is not provided, we start with the first thing of the array, the 0th index, which means we can skip that in the iteration and start I at 1 instead of 0. That means that down here, we do not have to specify let I equal something. Now, it might be more concise and make your goopy goblin brains happy to write this code out in the for loop, but because it's a little bit more complicated and it's related to the accumulator logic and the fallback code there, that redundancy code, if you will, it's a good idea to keep them paired up and grouped together there for separation of concern and clarity, but this is a preference or a pattern that your team may dictate, but it'll show that you have a stronger command or mastery over how to write cool JavaScript code. So guess what? We can just write a semicolon here and write our logic as is from there. Meaning, I can say, so long as I is less than the array's length, remember this represents the array, we increment our iterator I by 1 each iteration. So that leading semicolon is to skip that let I equal 0 step because we're doing that on a separate line of code. I hardly ever see this, but I thought it was worthwhile to include here just to make sure that we are all learning how to ace these crazy, goofy technical interviews with some cool things we can even discuss. So the whole purpose of the reduce, remember, is to take the accumulator, apply a callback function to it, and we're going to assign our accumulator whatever that happens to be, where we're going to say take the current accumulator into our callback, the current value, the index, and the array itself. That way it also matches up on the specifications. Remember, we had always written ACC or accumulator in our reduce code, comma, current val. Remember, it was like reduce. There's the callback function that we're talking about here. There's our accumulator. There's our current value. Accumulator, current value, and we also have, if we need it, the access to the index and the access to the array itself of whatever we're doing. So that's going to follow that same specification it has there. Then we simply need to return the accumulator after we are done doing it. So remember, in JavaScript, functions are first-class objects. The right-hand side of this whole thing will be evaluated. Whatever this callback returns will then be assigned to our accumulator, okay? And yeah, we can take this exact code and copy and paste it down here and turn this around into custom reduceRight. So remember, I said reduce and reduceRight. ReduceRight is the same thing as reduce, except instead of starting from the beginning, it starts at the end and goes from right to left inside of the array. So that'll only change a couple things here in our code. If we are not provided an initial value, then what we're going to have to do is something a little bit different. So instead of saying start at the beginning element, or the beginning value, we're going to say grab the array's final value, which is just the array's length minus 1 value. Otherwise, use whatever initial value we passed in. That makes sense. Then for this one down here, we're going to say if we have to start at the beginning of the array, technically that is the end in this code's case. But if we don't have to start at the end of the array because we grabbed the end of the array up here for an initial value, should it be undefined, then we can skip the end of the array and start from the second last end of the array. So that's the same logic that I discussed back up here, except in reverse. So keep that in mind. Then down yonder, I don't have to do the following. Instead of I++, we do I minus. Instead of I is less than the length, we simply say as long as it's greater than or equal to 0, it'll keep iterating downwards, and then this code shall remain the same. And that is all there is to it, folks. Let's console log an array, and I'll have const input numbers or input array or something like that. And we'll do, like my examples, 1, 2, 3, 4, 5. It's a combination of my luggage. We'll do a custom. I always write the wrong one first because my goblin brain's like, no, write what you know. So remember, that's our callback, our initial value. If we don't provide one, let's test it. If I don't provide an initial value, are we going to get some kind of error of writing undefined +1 or undefined +2? Are we going to get an error that says, you can't string concatenate these numbers to undefined or something like that? Not string concatenate. You can't like add these numbers to undefined, get not a number, and weird answers like that. No, we're going to see if my fallback code works here. But we're going to say our accumulator, whatever it happens to be, and our current value or our current number in this input array of numbers we're going through. Let's do some shorthand and say accumulator plus num. So that right there is an ES6 implicit, forget it. There, that is the proper way to write it without using a ton of shorthand. Let's see if this works now. That's 5, 10, 14, 15. Yeah, we got 15. I knew that answer right away, didn't I? Yeah, so if I can drop the keyword return, drop the curly braces, and move it all to one line, that is effectively the same thing. As you can see, if I save and refresh, the code works just fine. So now technically, again, stronger written code would dictate that I would need to provide an initial value, and we'll say 0 will be the initial value. If I'm getting an array of numbers, it does make sense to do it this way. Let's make sure that custom reduceRight doesn't have a different answer, because if it does, we are going to have a problem. Okay, thankfully it doesn't have a different response. It has the same response of 15, which is the same value reduced from the right-hand side. Now, to actually test this, let's see if we can go, what do I have? Yeah, A, B, C, D as my string array. So we're going to say input array. Boop. I guess num is a terrible name now. Let's change this to char or letter or whatever you want to call it. I don't think it really matters. So instead of an initialized value of 0, let's initialize an empty string. That way we can provide a correct initial value and iterate from the right-hand side. So it should be disaba, yeah, let's go. And if I switch back from reduceRight to simply custom reduce, we get A, B, C, D in the opposite scenario. So yeah, that is an implementation of reduce and reduceRight in our little code base here. So taking a look back up here, it's an incredibly versatile and powerful one to know. I really enjoyed doing some research and putting together this little video script here for y'all. I use reduce a lot, especially once I had my own aha moment of how versatile it can be, considering I can implement other array methods, which is something that you can actually flex on your interviewer in an interview should you find yourself doing some coding or discussing it and talking about how cool you are because you know how to implement other array methods into the reduce method. It will put you, again, that little echelon, that little tier above a normie that wouldn't know what this is or how to do so. So as always, data transformation and backend processes where you have tons of computations going on with data, like large data sets, especially in backend development, reduce is going to be one of your best friends over there. There's a specific lab in our course called Dicey Business that I always introduce the reduce method on anyone that has a lab review pending for that particular lab. Initialization, something we talked about, and I briefly mentioned this while talking about our own initial value. We wrote fallbacks for it, and I always wrote it out, and then I did a demo down here to make sure it worked without an initialized value of any kind. By default, the first item in the array will serve as the initial accumulator value. This is very important to know because it can cause or pose a problem if the array is empty or the logic depends on an external initialized value. So don't not write it in there just because you know what it defaults to. Again, the code is strongly written, but we also use the code strongly and concisely by providing an initial value and not just relying on fallbacks, even though we coded it there. So while I think this is an insanely powerful, versatile, and cool tool to know how to use, it can provide some overcomplication. Going, well, Luke, why would I write my own reduce that implements .map when I can just use .map? It can make it harder to read depending on what you're trying to do. Someone might go, why are they doing reduce when they could have just wrote .map? I don't know what's going on here. So, that overcomplication can be an issue if you're not careful. So I'm not going to do the timing on this one because this one ran a little bit longer since I showed some other use cases of reduce in this video. I'm not going to do the timing of the functions here and compare some times on them. I think y'all already know. If you haven't already, go watch the previous 2 videos on findIndex and filter, because that's where I do show some cool things to do with console time and time end, because based on the nature of the operations, the size of the data set, balancing readability with efficiency, whatever transformations you might be doing to your huge data set, as always, it is important to keep in mind that running a function callback on every single element of a large data set takes longer and longer and longer compared to just a hyper-optimized traditional for loop will still be the fastest way to do something should you need to. So yeah, just keep that in mind. Otherwise, there'll be a CODEPEN link for this. Remember to go down and check the description for both the CODEPEN and a link to our community membership if you're interested in signing up. Otherwise, thanks for taking this journey with me through this multi-factored and versatile, then word of the day, hashtag word of the day, versatile, world of reduce and reduceRight. So I'm going to continue to shed light on other array functions as I just scroll through the MDN docs and go, oh, that one's cool, and just pick it and learn about it and write a video on it. We're going to aim to bolster that coding arsenal of yours by watching this video series and getting involved in our community membership. So remember, if you found this deep dive beneficial, grace us with a thumbs up, a subscription, click the bell, all that kind of fun YouTube stuff. I'm terrible at marketing and self-promo. So yeah, hope you all enjoyed this. Keep that passion high, the energy high, and happy coding, y'all.